Hi Algebra 2, this is video 5. The learning target is I can recognize and factor the special cases of difference and sum of cubes. And this is our special case number 2. And it is a difference and a sum of cubes. You can factor both difference and sum of cubes, but you can't with the squares, and we'll be talking about that more in class. But the first thing I want you to do is list the perfect cubes. So go ahead and pause the video and try that. Now a cube, remember, is a number multiplied by itself twice. So it's written down 3 times. So 2 times 2 times 2 would be equal to 8. So 8 would be a perfect cube. So if we list several cubes, you can think of 1 because that's 1 times 1 times 1. And then again 8. And then 27 would be 3 cubed, 3 times 3 times 3. Another way to write it would be 3 cubed. And then 64 would be 4 cubed, 4 times 4 times 4. 125 is 5 times 5 times 5. And then again with variables, x cubed is x times x times x. So that's also a perfect cube. And you can combine them just like we did with the squares. So 27 times x cubed, both of them are perfect cubes, so they can be listed as a perfect cube combined. We have a formula for factoring the difference of 2 cubes and one for factoring the sum of 2 cubes. And then I also will be listing some steps on how to remember these formulas. The formula for factoring a difference of 2 cubes is written in purple. And notice that the difference just means we have 2 perfect cubes and one is being subtracted from the other. Our second formula, factoring the sum of 2 cubes, again we have 2 perfect cubes and it's a sum, so we have an addition between the two. The way we can help us remember these formulas is we have several steps. The first one is when you're going to factor 2 cubes is you're going to write a small parentheses and then a large one, because notice how the formula is set up. My second step is I'm going to take the cube root of both items. And place it in the small parentheses. So here. Our third step is going to be writing the signs down. And we help us remember with SOP, and that means the same sign, opposite sign, and always positive. And you can see how that works by the formula. So the signs, you notice that the difference one here, your first sign that you write in your parentheses is the same as the one here. Then your second sign will be the opposite of whichever you wrote here. And then always positive. This one is, and the last one is always going to be positive. Again, it's same as the original problem that you're factoring, then opposite, and then always positive. Our last step is we're going to remember it as square smash square. And what I mean by that is if we take the item, the perfect cubed, and we multiply it out, so a times a times a, so factor it out, and we look at b cubed, that would multiply out or divide out to b times b times b. And by what I mean by square smash square is you're going to take the first 2 parts of a here and we're going to multiply by them. So square, it would be a times a. Then we're going to smash, so the 2 in the middle, a times b, and then square the last two. So what's left is our b times our b, and that will get listed in our parentheses. And that's why the signs have to be written down first. So if we look at this first step here, where we take the cube root of both items, so the cube root of a cubed, remember, would be a. The cube root of b cubed would be b. So that would be written as a and b. Then we get our signs written down, where we have the same sign, opposite, always positive. And then we're going to square, smash, square. So we take a and multiply by itself. Then we smash them, so a times b. Then we square again, and we have b squared. Let's try number 7 here. So number 7 is a difference of cubes. And our first step, remember, is to write down a small parentheses and a large parentheses. Then we're going to take the cube root of both items. So the cube root of x cubed would be x, because x cubed would be x times x times x. And the cube root of 27 would be 3, because 3 times 3 times 3 is 27. So if we take the cube root of 27, it would be 3. Now we're going to write our signs down. So the same sign is here. So this same sign gets written here. Now the opposite of negative would be positive. Then we're going to write always positive. So same, opposite, always positive. Last, we're going to square, smash, square. So if we write out x times x times x and 3 times 3 times 3 to represent x cubed and 27, when we're square, smash, square, we think of x times x as the square, the first item that goes in here, and then smash our x times our 3, and last our square of 9. Okay, the difference of cubes and sum of cubes work the same. Just have to think about the signs. So if we looked at number 9, again our first step would be the small parentheses and the large. Then we'll take the cube root of both items. So the cube root of x cubed, remember x cubed is x times x times x. So the cube root of x cubed would be x. The cube root of 64 would be 4. Then we must write our signs down first. So the same sign, opposite of what you wrote here, and this last one's always positive. Now we're going to square, smash, square. So again, if we write them all out, you can also look at this one. So if we square x, these first two would be x squared. Then we smash them, so 4 times x. And last square, so 4 squared would be 4 times 4, which would be 16. Okay, we're going to be practicing these more in class. Hope you have a great night.